For the last 300 years, a debate has raged between mathematicians about who should be credited with the invention of calculus, Sir Isaac Newton or Gottfried Wilhelm Leibniz. The sides of the debate have mostly been based on geography, with English mathematicians advocating for Newton and Continental Europeans siding with Leibniz. Learn more about the war over calculus, even if you've never taken a calculus course in your life, on this episode of Everything Everywhere Daily. This episode is sponsored by Audible.com. If you want to understand calculus at a layman's level, the audiobook I would recommend is Infinite Powers: How Calculus Reveals the Secrets of the Universe by Stephen Strogatz. Though many of us were scared away from this essential, engrossing subject in high school and college, Stephen Strogatz's brilliant, creative, down-to-earth history shows that calculus is not about complexity, it's about simplicity. It harnesses an unreal number, infinity, to tackle real-world problems. You can get a free 1-month trial to Audible and 2 free audiobooks by going to audibletrial.com/everythingeverywhere or by clicking on the link in the show notes. For those of you who may not have taken a calculus course, fear not. I'm not going to be getting into the weeds of equations, and given that this is an audio show, that would be hard to do anyhow. Calculus roughly consists of 2 parts: integral calculus and derivative calculus. They are related to each other in a similar way that addition is related to subtraction and division is related to multiplication. Integral calculus is about finding areas and volumes. Derivative calculus is about determining rates of change. It does this by harnessing the power of infinity. For example, you wanted to find the shape of an irregular object, you could add up an infinite number of tiny squares. It was figuring out how to make a system that allowed for the use of infinity, which was the real trick behind calculus. Calculus is the reason behind modern engineering and science. Everything, and I do mean literally everything, from computers to buildings to cars, is dependent on calculus. Figuring this out was no small accomplishment, and if attribution in mathematics and science means anything, then it would mean something in the attribution in calculus. We'll start the case for Isaac Newton. Newton was a really smart guy. In fact, he single-handedly probably did more for the advancement of science than any other human in history. He figured out the laws of motion, gravity, and light. Any one of those things would put him in the pantheon of science greats, let alone figuring out all 3. And on top of that, we're talking about him discovering one of the most important entire branches of mathematics. Newton's work began when he was 23 years old and working on the problems of physics. In order to solve the problems he was working on, he had to develop a new system of mathematics to go with it. He invented a system he called fluxions. In 1671, he wrote a book called A Method of Fluxions, which describes his new system. The problem was that Newton never published his work. Other than himself and a few of his colleagues, no one knew about the system he had developed. Had Newton published his work and made it public, this entire controversy would never have erupted. In 1674, Leibniz began working on his system of calculus. 10 years later, in 1684, he published a system in a paper called Nova Methodus pro maximus et minimus, or A New Method of Maximums and Minimums. Newton later did publish his work fully in 1704 as an appendix to a book on optics. Newton and his supporters in England were adamant that Leibniz plagiarized calculus from Newton. Their argument starts with a trip that Leibniz took to England in 1673, the year before he began working on calculus. He didn't meet with Newton during this trip, but he did spend time with 2 of Newton's associates at the Royal Academy, Henry Oldenburg and John Collins. And during the trip, he might have learned secondhand about what Newton was doing. After the trip to England, he kept up a correspondence with Oldenburg and Collins, where they discussed mathematics. He then had a similar controversy come up when he came up with a solution to a problem for infinite series, which had already been published by someone else, and that just added fuel to the case for him being a plagiarist. Before 1677, Leibniz never mentioned anything to anyone about calculus. A year before, in 1676, he supposedly received a package of letters which included a 1672 letter from Newton to Collins, which explained his fluxion calculus. So according to the Newton supporters, he had a full year to study Newton's system and claim it was his own. All of this seems pretty damning. The Royal Society did an investigation into the matter and published their own findings in 1713, which said that Newton was the discoverer of calculus. The president of the Royal Society at the time of the investigation? None other than Sir Isaac Newton. So, what about the defense for Leibniz? Most of the accusations towards Leibniz are circumstantial. Yes, he was in England twice, and he met with mathematicians, but there's no evidence that he really learned anything or spoke with anyone who would be in the know about Newton's calculus. Also, on his first trip, he was really young and hadn't even started a serious study of mathematics. There really isn't a smoking gun. The letters which Leibniz received from his colleagues in England, which did mention parts of calculus, were mostly overviews and didn't go into any detail. Moreover, the system which Leibniz developed was different from Newton. Yeah, the core of it was the same, but the system of notation he developed was far easier to use than Newton's, and that became the basis of the calculus we use today. Researchers haven't really found any evidence to prove or even insinuate that Leibniz stole the idea for Newton. If this were to be a case brought before a court of law, there might be enough to bring about suspicion, but there wouldn't be enough evidence to convict. So it's been documented that Newton definitely figured out his system first, but that he never told the world about it or published it. Leibniz discovered his system later, but he definitely published it, whereas Newton didn't, and there's no evidence to prove that he took the idea from Newton. If someone were to prove that he did, you could simply say that he improved on Newtonian calculus to create the system that we use today. The consensus among historians and mathematicians today is that the two developed calculus independently. However, that isn't quite the end of the story. It might be that someone actually discovered integral calculus before either of them. Way before either of them. Most of the written works from antiquity have been lost to history. Fires like the fire in the Alexandrian Library and other events over time have resulted in the vast majority of works from the distant past to be lost. Every once in a great while, such a document is rediscovered. Such a document was discovered several years ago. It was erased from the pages of an ancient Byzantine manuscript, so the paper could be reused as a prayer book. But with modern techniques, it was possible to read the text. The book is called the Archimedes Palimpsest, and it contains one of the lost works of one of the few people who could rival Newton for the title of the greatest mathematician/scientist in history, Archimedes. In this, there is a section titled The Method of Mechanical Theorems, where Archimedes describes how to calculate the area of curved shapes using a technique which closely resembles what we now call integral calculus. He figured out how to calculate areas using an infinite number of small triangles. The technique was very limited with what could be done, and it wasn't a fully developed system of calculus, and he hadn't discovered a system for doing differentiation. That being said, Archimedes laid the foundation 1,800 years before Newton or Leibniz. If the work hadn't been lost for centuries, calculus and all the science which stems from it could have been discovered hundreds of years earlier. Executive producer of Everything Everywhere Daily is James Makala. Special thanks to everyone who supports the show over on Patreon. Please remember to leave a review over on Apple Podcasts. Even a simple review can really help the show get discovered in the sea of other podcasts that are out there.